Good morning, class. Today you're going to watch your first video of this unit. It'll be lesson 1. Our goal today is going to be to solve exponential equations. So again, we're just looking at the exponential equations. Later we're going to get into logs. The first example I have here for you today, you actually already know how to do. You could have answered a question like this on the last test because they have a common base. So what we're looking at here is just like you would have done on your test before. Get these two so they actually, the base is the common. So I'm going to break down 16 to 4 times 4, which is 2 times 2. So 16 is technically 2 to the 4th, but I still have that 3x there that I'm going to use. Then I have to break down 8 the same way because that's not a base of 2. And I notice I get 3 2's there. So 8 is the same as 2 cubed. Now, on your last test, once you had the same base, you just set those exponents equal to each other. We're going to do the same thing. So 4 times 3x, if you wanted to put 12x right away, you could. But that's going to equal 3. So 12x equals 3. I want to divide by 12 because that's the number next to the x, not 3. It's a fraction, and that's okay. So I'm going to get 3/12 or 1/4. And that would be your answer. So again, if you can break down the bases, you can go back and do what you've done before. Get them so they have a common base, and then set those exponents equal to each other and solve. Perfect. However, now we're going to look at some that we can't get a common base. So for instance, 15 times 15 in example 2 does not equal 285. So there is no common base between those two. So we have to come up with another way to solve. What I'm going to show you now works 100% of the time. So if you don't want to ever get a common base on the next test, you don't have to. But you can if you want, if you find it easier. But there will be some examples where they're different. What we're going to use is we're going to use logarithms because we learned in the last part of the unit that that is the inverse of an exponential. So we want to undo it, right? We don't know in this example A here if x is 3 or 2 or what it is. So what we're going to do is use logs. So how do we do that? Well, we honestly just write the word log on both sides of your equation. So we'll have log base 10, because we're going to use a calculator, of 15 to the 5x, and that's going to equal the log of 285. Now you're saying, well, the exponent is still an x. That doesn't help me. But now we go back to those properties of logs, and remember that exponent can be brought out front. So we actually get 5x times the log of 15, and that is going to equal the log of 285. So now you can notice we're taking the 5x times the log. So to undo that, I'm going to divide both sides by the log of 15. And in a few seconds here, I'm going to actually show you how to type this into your calculator. And you'll be using graphing calculators for the upcoming test. So that's how I'm going to show it to you, is using our graphing calculator. So what we're going to do right now is I'm going to switch screens and we're going to look at how to type that into the calculator. So here's my graphing calculator. You'll see the word log here. So that's the button we're going to use. And our number that we had was 285. Here's the key. You have to put that parenthesis in after that log and then divide, because that's showing you're taking the log of 285, whatever number that is, and then we're going to divide it by the log of 15. If you don't have that parenthesis in there, it's taking the log of everything together, and that is not what we want. So we get 2.019, so that is what I'm going to write on to our notes here. So I ended up getting 5x equals 2.09. You guys know how to solve that now. Divide both sides by 5. So our x is going to equal 0.417. And again, you could, if you wanted, type that back in up here and make sure you get 285. It'll be rounded, so it might not be exactly 285, but it would be close. You would know if you did it correct before you moved on. All right, I just have one more example to look at here. So we're going to do this one, and then I'm going to have you try 2 on your own and see how those go. The difference between A and B is you notice there's a number out front here now. Just like in the past with square roots, cube roots, we had to isolate that. We had to get that by itself. So we're going to do the same thing here. So we are going to divide both sides by 3. So we're going to get 4 to the x minus 3 equals 7. Now we solve it the exact same way that we did part A. I should have mentioned this earlier. At any part during this video, if you're watching it in class and you're like, oh boy, I'm stuck on something, raise your hand. I'll come by and help you. Rewind, watch again and see if that helps. You're sitting in groups. Ask each other as you're watching the video if you have any questions. So definitely think of this as still asking questions just like you could before in class. All right, let's finish this up. We're going to take the log on both sides. I'm going to keep drawing these parentheses in just so you get in the habit of putting those into the calculator. Some of you might do this orange and green step or second and third step, whatever you want to call it. You might do this as one. Some of you might remember right away to bring that exponent out front. So if you want to do that, if you want to skip that orange step because you think you're going to run out of room, go ahead. I am okay with that. I do need to see the other steps though. I like to show it this way so I remember I'm using that property, but some of you you'll practice and you'll be like, I'm just going to pull that out front, and that's perfectly fine. So just like before, this x minus 3 is being multiplied by that log of 4, so I'm going to divide both sides by log of 4 because then those cancel, right? Those are gone. So then I have log of 4 here. So what you could do is now on your own, try to type this in. And if you don't get the right answer, please, please, right away, raise your hand and I can come help you type it in and make sure we've got that part. But if you type in log of 7 and you divide it by log of 4, you should have gotten 1.04 or 1.4 if you rounded it differently. That's fine. Then we're going to add 3 on both sides. And you have your answer. So x in this problem would be 4.404. And again, you could plug it in and see if you get 21 into the original problem if you would like. What I'd like you to do right now is pause the video, try the bottom 2 at the end, and see if you can get the answer. I'm going to share the answers so you can check them. But again, yes, you could write down what I have, but I would try it on your own first and make sure you've got it before you move on. Here's the 2 answers. So for A, again, that 2x would come out front. When you take log of 130 divided by log of 5, you get the 3.024, divide that by 2, and you get 1.5. On part B, again, you notice that this is not isolated the way it is, so the first step is to add that 3 over and then solve it, and you should have gotten 1.953. You are done with the first video, so now what I would like you to do is go to the next page, page 2, work on those practice problems, and once you are ready for that first mastery check, please let me know, and along the way, ask any questions you have. Thanks for your time. Have a good day. Where did my video go? Not again.